Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering. I work as a theoretical physicist and as a systems and mechanical engineer. I also work as a theoretical economist and operations researcher. Now, my theoretical physics mentor, Julie B. Larson, was also a theoretical economist. I've made all of his work in physical science fully computational, and over the past few years, I've made all of his economics work, his theoretical economics work, fully computational. The theory is similar to Austrian theory with the difference that it's computational. There's really no math in Austrian economics. It completely supersedes the nonsense you learned in college of the Keynesian theory and all their little variations of it. I've already covered microeconomics in the first few lectures, so now we're going to go with macroeconomics. So here we go. And by the way, I'll give a link for the paper. It's free. You can download it. It's a PDF. So here we go again. Macroeconomics deals with the aggregate quantities of production, consumption, and prices in a given country or region having its own currency. Here the fundamental equation of economics, which is equation 1-1c, becomes B sub aggregate equals P sub aggregate times V sub aggregate in dollars. That's of course nominal. P sub aggregate is of course the general price level of the country or region. Economists choose a certain base year in which to express currency values in subsequent years in order to get the true values for economic growth and inflation. Signifying the base year with a subscript of 0, we then have B sub aggregate 0 equals P sub aggregate 0 times V sub aggregate 0. Again, B is purchasing power, in case you forgot. By the way, you should read the microeconomics sections first, or listen to the tapes first. The screencasts first for microeconomics. Anyway, continuing. The total purchasing power created in the base year, which is B sub aggregate 0, is obviously the gross domestic product, GDP sub 0. So we, of course, have B sub aggregate 0 equals GDP sub 0, and that's in dollars, or whatever currency you're using, euros, whatever. It will be convenient what follows to solve for P sub aggregate 0 in equation 3.1b. So this is obviously P sub aggregate 0 equals GDP sub 0 divided by V sub aggregate 0. Again, V is volume, incidentally. And this is the dollars per unit. For the base year, we know the aggregate price level. It's set to an index of 100. That's the CPI. We also know GDP sub 0, of course. And so we know V sub aggregate 0 by equation 3.3. To calculate the values of these quantities for the following year, which is designated year 1, we have to modify each quantity of equation 3.3 by a series of factors which represent the changes in the economic conditions. Okay? Let me repeat that. To calculate the value of these quantities for the following year, which is year 1, we have to modify each quantity of equation 3-3 by a series of factors which represent the changes in economic conditions. Okay, so we're at sub A here. Net consumer reservoir extraction or injection. Remember that consumers have various reservoirs like savings accounts, money under the bed, whatever. So they can either put money into those reservoirs or take it out. So now let's let C sub res 1 equal the rate of change in the consumer reservoirs considered either positive and extraction from the reservoirs to put into the purchasing power stream, or negative and injection into the reservoirs. So by principle 8, this change modifies both sides of equation 3-3. So C sub res 1 equals minus the quantity I sub 1 minus I sub 0. And the I's here are the investment quantities, year 1 minus year 0, divided by GDP sub 0. Remember, everything is relative to the base year. So then we now get P sub aggregate 0 times 1 plus C res 1 equals GDP sub 0 times 1 plus C res 1 divided by V sub aggregate 0. Okay? And that's in, of course, dollars per unit. We're dealing with nominal values here. We can identify C res 1 as the negative of the change in the gross investment rate of the private sector. Okay? The negative of the change in the gross investment rate of the private sector. If more is saved in year 1, then consumption will be relatively less. And so P sub ag 1 and GDP sub 1 will be lower than those of year 0. But the savings go into investments, which will then increase the GDP over the long term. So even though there's less consumption in the year, over the long run, it might be better if productivity is increased by means of the investment. Okay, section B, increase in volume of production due to change in the number of workers or worker hours. The number of workers or worker hours of a country can increase or decrease, causing a change in the volume of production. Let A sub vol 1 equals the ratio of the number of year 1 workers n sub 1 to those of year 0 n sub 0. So this equation here, 3-6, A sub vol 1 equals n sub 1 over n sub 0. Pretty obvious. By principle 9, we then have P sub ag res 0 times 1 plus C sub res 1 equals GDP sub 0 times the quantity 1 plus C res 1 times A vol 1, which we just calculated, divided by V sub ag res 0 times A vol 1. Therefore, the aggregate price level is not affected by this factor. All right, section C, producer-retailer responds to changing consumer reservoir levels. So the producer-retailer changes depending on whether consumers are putting money back into the reservoirs or taking it out. So during a recession, of course, consumers stop spending, and whatever income they have, they'll put more into savings somewhere. So producer-retailers may respond to a change in the consumer reservoir levels either by changing the volume of their production or changing the price, which is pretty common, or both. So let Y sub vol 1 equals decimal change in volume due to change in consumer reservoirs by means, say, of a change in capacity utilization. And let Z sub P1 equal the change in the price level. So we then have P sub aggregate 0, that's the average price level in the base year, times 1 plus Z sub P1, where Z sub P1 is the change in the price level, equals GDP sub 0 times 1 plus C res 1 times A vol 1, divided by V sub aggregate 0 times A vol 1, 1 plus Y vol 1, okay? And again, Y vol 1 was most likely would be the change in capacity utilization. Okay, so here's Z sub P1 has replaced C res 1 on the left-hand side of the equation because of the possible change of volume. And so remember that 1 plus Z sub P1 equals 1 plus C res 1 divided by 1 plus Y vol 1, okay? Now, section D, change in average wage rate. Suppose the workers manage to get a pay raise in year 1. Let F sub W1 equal the decimal change in average wage rate plus fringe benefits. Now, so we're including fringe benefits as part of our average wage rate. 1 plus this factor multiplies both sides of equation 3.7 without changing the volume. So this doesn't change the volume. So we now have the base price level times 1 plus Z sub P1 times 1 plus F sub W1, which is the change in the wage rate. So that equals GDP sub 0, that's the base year GDP, times the quantity 1 plus C res 1 times quantity A vol 1 times 1 plus FW1. Okay, and divided, of course, by the aggregate level of volume in year 0 times A vol 1 times 1 plus Y vol 1. Now, section E, change in average productivity. This is a very important factor. Continual technological improvements cause average productivity output per worker to rise, usually. Now, many decades ago it was usually 3% a year, but in more recent years it's become pretty anemic. Let A sub prod 1 equal decimal change in productivity, volume increases, and the aggregate price level drops. So this is a good thing. We're producing more, so the price level is going to drop. So again, reading 3-11, this equation, this is P sub aggregate 0, that's the aggregate general price level in year 0, times the factor 1 plus Z sub P1 times 1 plus FW1, that's the change in wage rate, divided by 1 plus the change in productivity. So the price will come down if the productivity is positive, of course. I mean, rarely it has been negative, but almost always it's positive. Equals GDP sub 0 times the factor 1 plus C res 1 times A vol 1 times the factor 1 plus F sub W1 divided by V sub aggregate 0 times A vol 1 times 1 plus Y vol 1 times 1 plus A prod 1. Okay? So we divided both sides of the equation by 1 plus A prod 1. Obviously, if wages increase at the same rate as productivity, there would be no inflation due to wage increases. So just take a look at that. Look on the right side of equation 311. You see 1 plus F sub W1 divided by 1 plus A prod 1. So if the rate of change of wages is equal to the rate of change of productivity, there's not going to be any change in the general price level. But if the rate of wage increases outpaces the rate of change in productivity, then the price level is going to go up, unfortunately. And that will mean that other workers, in fact, will have to pay for that additional amount. All right, so now F, effects of exports and imports. Exports do not change the domestic volume quantity, but they do change the domestic purchasing power and the price. Imports change the domestic volume and the price, but not the purchasing power. So let X sub 0 equal exports in year 0, and X1 equal exports in year 1. These are nominal values, of course. Let import 0 equals imports in year 0, and 1 imports in year 1. Let delta X equal decimal change in exports relative to GDP 0, and delta import equal decimal volume change in imports, again, relative to GDP 0. So if delta X equals X sub 1 minus X sub 0 divided by GDP sub 0, and delta imports equals V sub imp 1 minus V sub imp 0 divided by V sub aggregate 0, or delta imports equals import 1 minus import 0 divided by GDP 0. Okay? Again, it has to be relative to the GDP 0 by proportionality. All right, so now we have this long equation in 314. This is the dollars per unit. I'm not going to read this off. You can see it on the screen very clearly. It has all the factors we have so far. But I do want you to take a look at the ratio of the change in exports to change in imports. The aggregate price goes up with an increase in exports. It comes down with an increase in imports. In fact, one of the reasons why the U.S. economy in recent years has had low inflation is that we've had so much in the way of imports. If there's no difference in imports or exports between year 0 and year 1, or if the change is the same for both, there's no effect on price or volume or GDP. Pretty interesting conclusion. All right, now we got to bring in the Federal Reserve. Hate to do this, but it's got to be done. Section G, Federal Reserve open market operations and velocity of circulation. And by the way, It's unfortunate that so many people in the Austrian economics community don't consider velocity. A lot of them just consider the quantity of money circulating, but really you have to consider both. All right, so the Federal Reserve can sell government bonds to the public and then retire the currency in order to fight inflation. Or it can buy government bonds from the public in order to fight deflation. A G sub 1 equals the decimal change in government credit goods, specifically treasury bonds, positive if sold to the public or negative if bought from the public. Also, let V sub 1 equal change in velocity of circulation of monetary base. All right, so then equation 3.9 becomes equation 3.15. Again, I'm not going to read this through, but I just want you to know, just look at the one modification, there's a 1 plus g sub 1 factor on the left-hand side and a 1 plus g sub 1 factor on the right-hand side. All right? So there's the government influence on this equation. So please note, if G sub 1 is negative, credit goods are purchased by the Fed from the public with newly printed money, which enters the purchasing power stream, raising prices. All right? So you can see that from the equation. If G sub 1 is negative, it's going to raise the price. If G sub 1 is positive, credit goods are sold to the public by the Fed and an equivalent amount of currency is retired. So that's the whole basis of operation of the Open Market Committee. As Dewey Larson says in reference to page 174, quote, the outstanding advantage of this method of purchasing power control is that no individual gains or loses by the transactions. Exchanges that take place simply substitute an asset in one form for an asset of equal value in another form, and the desired effect on the economic system is accomplished without disturbing other economic relations, end quote. At first, it might be thought that G sub 1 should be the decimal change in M1, but upon reflection, it should be the decimal change in M0, so-called high-powered money, or the monetary base. Yeah, it has to be on the actual currency base. All right, now we got to look at the famous economist Fisher, and he's the one that actually knew about velocity. So the Fisher identity is GDP sub 0 equals M0 sub 0 times the velocity sub 0, where velocity sub 0 is the velocity of circulation of M0. Likewise for GDP sub 1 equals M0 sub 1 times the velocity sub 1, okay? But M01 and velocity 1 can be written so that with G1 being negative for an injection, it's important that you understand the signs here. GDP sub 1 equals M0 sub 0 times the factor 1 minus G1 times velocity sub 0 times the factor 1 plus V sub 1, where V, that small v sub 1, is the change in the velocity of circulation of M0. So then from equation 316a, we get GDP sub 1 equals GDP sub 0 times these two factors, 1 minus G sub 1 times 1 plus V sub 1. Okay? So that's from 315, 1 plus C res 1 times A vol 1 times 1 plus FW1 times 1 plus delta X equals 1 minus G sub 1 times 1 plus V1. The value of G sub 1 is easily obtainable, whereas V sub 1 is not, but equation 316d can be solved for V sub 1, and we get, for the velocity, V sub 1 equals GDP sub 1 plus GDP sub 0 times G1, or I should say G sub 1 minus 1, divided by GDP sub 0 times G sub 1 minus 1. Clearly, and that just cancels out, but clearly V sub 1 is not an independent variable. All right. Okay, now let's get all the year 1 quantities. So by inspection equation 315, we can see that the aggregate price level in year 1 equals aggregate price level of year 0 times the factor 1 plus Z sub P1 times 1 plus F sub W1 times 1 plus delta X, all divided by 1 plus A sub prod 1 times 1 plus delta imports times 1 plus G sub 1. GDP sub 1 equals GDP sub 0 times 1 plus C res 1 times A vol 1 times 1 plus F31 times 1 plus delta X. And so V sub aggregate 1 equals V sub aggregate 0 times A vol 1 times 1 plus Y vol 1 times 1 plus A sub prod 1 times 1 plus delta imports times 1 plus G sub 1. Alright, so section I. Taking the ratio of year 1 to year 0 values. So from the fundamental equation, let's go back to the fundamental equation. P sub aggregate 0 is GDP sub 0 divided by V sub aggregate 0. That's the base year. And the following year is P sub aggregate 1 equals GDP sub 1 divided by V sub aggregate 1. And so the ratio is given there in equation 320. So now using equations 317, 318, 319 in equation 320, we get P sub aggregate 1 divided by P sub aggregate 0 equals that expression there that you see, which I'm not going to read again. But, of course, the factor A vol 1 drops out from the numerator and the denominator, and the ratio of P aggregate 1 to P sub aggregate 0 can be recognized as the ratio of CPI 1 to CPI 0. So now we get the CPIs in here. CPI sub 1, that's CPI in year 1, divided by CPI in year 0 is equal to that right-hand side that you see there for equation 322. And, of course, CPI sub 0 is just set to 100 by convention. And so we get CPI sub 1 equals CPI 0 times that factor, equation 324a, that's the index. And so the inflation rate is simply inflation in year 1 is equal to 100 times CPI 1 minus CPI 0 divided by CPI 0. Or inflation sub 1 equals simply CPI 1 minus CPI 0. Right? If inflation sub 1 is known or estimated, or CPI sub 1 is known or estimated, then Y sub vol 1 is determined. So we get this change in volume of production. Pretty complicated equation there. To get the true growth rate of the economy, we need to take into consideration the inflation to get GDP sub 1 expressed in the value of the currency in the base year. We must multiply by the ratio of CPI sub 1 to CPI. I'm sorry, the ratio of CPI 0 to CPI sub 1. So, this is important. So, GDP sub 1 true is equal to GDP sub 1, the nominal value, times the ratio of CPI sub 0 divided by CPI 1. So, if CPI 1 is greater than CPI 0, you can see that the true value of GDP is less than it would be otherwise. So, therefore, the true growth rate in GDP is GR sub 1 true equals 100 times GDP sub 1 true minus GDP 0 divided by GDP 0, and that's percent. All right, so now we can get the optimal federal open market operations, this is section J. From equation 310, we can solve for G sub 1 in order to get precisely 0 change in aggregate price from year 0 to year 1. So the goal here is not 2% inflation, 0% inflation, actually. So there you can see in equation 328, that's a decimal change in G sub 1. In order to get, in order to set P sub aggregate 0 equal to P sub aggregate 1, which means 0 inflation, then G sub 1 optimal of 0 is equal to this factor, 1 plus FWT times, FW1 times 1 plus delta X times 1 plus ZP1 divided by 1 plus A prod 1, 1 plus delta import times 1 plus Y. I'm going to stop using the word sub there. That's for 0 inflation. I'm of the opinion I'd rather see a gentle 1% deflation, and I think that would be even more desirable because it would help with saving, which in the long term helps with investment, which in the long term helps productivity, which then raises the standard of living. So this is the value for G sub 1 optimal minus 1, the M1 is minus 1, equals 100 over 99 times that factor in the brackets, minus 1. That's for 1% deflation. Now keep in mind there's a time lag for FOMC operations. It would probably be best to use equation 320 and equation 330 each quarter based on the change in the values of the parameters projected for the year from measurements in the quarter, and then dividing the value of G1 by 4 to get the quarterly value to use in practice. Okay, so that's what I'm recommending. Just do it once a quarter. Now we'll go to section K, income share of capital and labor. And this is probably the last one we'll do today. From Principle 5, nominal GDP sub 1 can be expressed as the sum of the returns to capital and labor. So GDP sub 1 equals R sub 1 times K sub 1 plus W sub 1 times N sub 1. R sub 1 is the effective or equivalent rental price of capital in year 1. It's a decimal. K sub 1 is total capital stock in year 1 in dollars. W sub 1 equals wage or salary per year in dollars. And N sub 1 equals the average number of workers in years 1. If we let beta equal the share of income received by the suppliers of capital, then 1 minus beta must be the share of income received by the workers. This then means that R sub 1 equals beta times GDP sub 1 divided by K sub 1, and W sub 1 equals 1 minus beta times GDP sub 1 divided by N sub 1. The value of beta cannot be computed theoretically at this time. Empirically, reference 4 states that beta equals 0.3. That is, the return to the capital is 0.3 or 30%. And that's what we're going to use. But other references say 0.25 and 0.33. But we're going to use 0.3, which means that the workers get 0.7 or 70%. To get the true rate of return to capital, we must subtract the depreciation rate of capital delta, the inflation rate, which is inflation 0 sub r divided by 0 to 1 divided by 100, and the effective tax rate on capital, which is tau sub K1. So there's the equation for R sub 1 true with all those factors. So that's really the return to capital. And well, I'm going to stop again in this section. By the way, K sub 1 equals K sub 1 true. To get the disposal value of the wage or salary, we must subtract the effective wage tax and neglecting any government transfers, which should be 0 on net. That is, over the lifetime of the worker, the wage transfer should be 0. So we get WB sub 1 disposable equals W sub 1 plus B sub 1, which is the investment income to the worker, if he has any, minus TXR sub 1 divided by N sub 1. Okay? And that does it for today. Please study this paper carefully. Now, I have automated all this in my commercial software program, Optimal Economist, and implementation of Larsonian Econophysics. And I include the spreadsheet in there as well as a FileMaker database. So you don't have to worry about all these equations all built into the software. Originally, we were going to sell that program for $295, but because of the recession/depression that we're in, it's going for a mere $95. Available from Amazon and TranspowerCorp.com. All right, well, that does it. And again, I'm going to give a link down below to the paper. Please study it, prove it for yourself, and thanks for your attention.